Welcome back to OOP with Java. In this exercise, we'll be creating a little simulation where we allow the user to enter names for robots, and the robots will start randomly fighting each other, and then they will fight each other as long as the user wants, and when the user wants them to stop, then they can just click finish, and it's all friendly war. But then we will then see the total results of what the fights were. So this project involves a process of instantiating robots. So it's inherently object-oriented, and we'll go ahead and start by creating a main class to kick off everything. So we're using Eclipse. One of the reasons we're using Eclipse is because Eclipse helps with the pre-compiling process. It helps us to see constraints of the Java language and missing things in your code. So it's a good way to help you to learn the language. So I start in the main class first. Well, first thing we need to do actually is to create a new Java project. If you don't see Java project here, you can just go to New Project, and then there's a drop-down menu here, and you can then type Java project from here. Then you give the project a name, and then we can just call it bots, Z. So we got a project. The project has a source folder which is empty. When we create new classes, those classes will be automatically added to that source folder. So we go to File and then New Class. We want to create a class that has a main method that will be our driver class. So we want to check this box here to give us that main method, which you should be familiar with now if you've been following the lessons up to this point. And the name for that, we could just call it bot start. This really could be anything for this class. We go ahead and click Finish. It gives us a class with a main method. Now, in order to get input from the user, we're actually going to import a library that's part of Swing, which is a graphical components library. And what we're importing is the JOption pane. So import javax.swing.jOption pane. Then here we're going to basically just do a test just to make sure our JOption pane is working. So we can do string message equals JOption pane dot show input dialog. What is your name? And then we will then do a system.out. Your name is whatever they typed in. So this is really your hello world thing just to make sure JOption pane is working properly. And it should be print line. Spelling is essential. So we run this code now by pressing the green button here in Eclipse. It asks us, what is your name? And your name is Fubu. Aha, your name is Fubu. Very simple. Now, when getting integers, we have to parse the integers because you know, the JOption pane returns a string. So it would be a similar thing. What is the number? And then we can say int the num equals integer dot parse int message. And then to verify that we've actually gotten a number, we can say, system.out your number added to 7 is, and then we can add the num plus 7. So we get a number, and we put in 7, and that number then parsed and then added to 7 gives us 14. So we'll go ahead and pause the video now, and then when you're finished making sure that your JOption pane is working, then you can proceed. Okay, now that you're able to get some user input, then we can start looking at the process of instantiating bots. So the first thing that we want to do is to create a new bot class. Everything in Java is organized in classes. So we can create a new bot class by going to File and then New Class. If you're working just in a text editor, you would just create a regular class the way you've been doing up to this point. We do not need a main method in the new bot class because we already have a driver class. All we need is a class called bot. So when we do this and click Finish, then this creates a bot.java class. In order to create or instantiate a new bot, you need a blueprint. You need a set of instructions. For example, if you're creating a new car, the car needs a name, it needs a make, a model, and it needs all of these things that come with every car. So a robot is the same way. Every robot needs to have certain features. And our robot will get its new features from our constructor. So the way to create a constructor is we just say public bot. So this kind of looks like a method, but it's not the it is a method in a sense that it is taking in the parameters that are sent in to instantiate the bot, and it's called every time we create a new bot. So in this case, we want to create a public bot, and we have a default constructor here. We're going to then create some fields that are going to be present in every bot. We've said that we want a name, and then we said we also want a strength. So we'll just do very simple string name and int strength. So when somebody creates a new bot, it will accept the parameters coming in that need to be the name and the strength. So we want, let's say, string n coming in and then int s. Now I've called these n and s to illustrate that it really doesn't matter what comes in here. We could say this is string handle and this is int force. Doesn't matter. These variables are thrown away once we instantiate the bot. But we use these variables to tie in what the user says they want the new bot to be, and then these class properties of the bot. So for example, when we create a new bot, we want the name to equal whatever was passed in as the handle, and we want the strength to be whatever was passed in as the force. So now when we go back to our driver class, we can take away this JApp-Champagne stuff for now, and we can create a new bot. It can't do anything because it doesn't have any methods, but it can be instantiated. So when we create a new integer, right, we would do int, let me just say int age equals 10. And then we create a new string. We could say string something equals blah, or string something equals new string blah, something else. All right. So when you create a new bot, you use the same type of syntax. You want to start by naming the thing that is being instantiated, or the thing that is being created, and then the name, and then the value. So we can say bot Fred equals new bot, and then pass in the parameters. We know that he needs a name, and we know that he needs a force, or really which is his strength. Let's just say 22. So we've got Fred here, and then so now when we type in Fred dot, it already knows that Fred is an instance of bot, and it's already giving us some of the properties of Fred. he has a name, and then he has a strength. He also has other properties that have been inherited that he gets that are inherited from object, which is a master class. So there is a level of inheritance going on here. We'll talk a little bit more about inheritance later. But essentially, we've created a new bot named Fred here. And here we can do system.out.println Fred.name. So it creates a new bot named Fred, and then it does his name. So, or we could say strength, same thing, of 22. So we've successfully created a new bot named Fred. We'll go ahead and pause here. Resume the video when you've been able to create an instance of a new bot. Okay, now that we know how to instantiate a bot, you're actually going to do some real work, and you're going to write some methods for us for our bot so that the bot can have instance methods. Now, we'll do one together. We'll do a couple together, actually, to show how this process works. So each bot can do various things. We want to have a bot to be able to speak. So we can create a method for the bot called speak. So if we do public speak or public void speak. So this method here is a public method. It's void, meaning it does not return a value. And then this is the method name. So we could say system.out.println I am a bot named name, and I have a power of strength. So in here we can say Fred dot, and if we once we click dot, we see speak is one of the methods here. So we can just do Fred dot speak. So now if we run this, I'm a bot named Fred and I have a power of 22. So this method really didn't do a whole lot. It did a system.out. We could return a string and then we could say string message equals Fred.speak, and then system.out.println message, and that will give us the same thing. So the methods here work the same way a method would be if you created a static method in this main class. You can call it, and depending on what kind of return value you're getting back, then that determines how you use that method. So since we know how to return a value with the method, we want you to write a method now that will return the strength without the speak method, or you can keep the speak method in there, but we want you to write a method that will just return the strength of the robot, and we want you to return it as an integer. So what we want is write a method to return the strength of the bot. All right, write that method and come back when you're done. Okay, so we're wanting to write a method to return the strength of the bot, and so you should have been able to figure out public int get strength. And then we just want to return strength. Now you can also do return this dot strength, and that's also valid. This in this context refers to the scope of the instance of the bot that we've created. If this were a static method, this would return would refer to the class itself. But we'll talk a little bit about static methods later. So we've got getStrength here. And this is what we call a getter method, and you probably saw this in your earlier lessons. And so then now we want to write a method that increments the strength of a bot, of the bot, really a bot. So write a method to increment the strength, and I tell you, if I spell strength correctly, I will be winning. Write a method to increment the strength of a bot. So we want to write that method now and then come back when you've completed that. Okay, so we just got finished doing a getter method, and then this would be our setter method. So we want to set strength, and this will, if you just are incrementing, some of you might have done something like this, not returning anything, this dot strength plus plus. Others of you may have done something like this dot strength plus equals value, and you accept their value. Either of those should work. So if we say Fred dot increment strength 10, and then we do Fred dot speak speak returns a string now, so let's do public void speak and then system.out.println. I'm bot named Fred and I have a power of 32. So either of those would have worked, doing a this.strength plus plus or this.strength plus equals a value and then passing in a value. All right, very good. So now that we know how to instantiate a bot, let's then have the user actually be able to create some bots by using the user input process. So using our JOption pane, we can say, we can decide to do this. I'll start this process and you're going to finish it. We'll say string bot one name equals JOption pane dot show input dialog. What is the name of bot one? So remembering this syntax, you should be able to collect the names of bot 1 and bot 2 and then also the relative strength. So what we really would like to see, it doesn't really matter which order you do it in, but you might want to get bot 1 name and then get bot 1 strength, and then do bot 2 name and bot 2 strength, but you're going to be opening up several different input dialogues and getting all of the data for each of those bots. So go ahead and do that and then come back when you're done. Okay, now some of you may have gone ahead and instantiated your bots after collecting the data. I know there are a few people watching this video who did that, and that is totally fine. So we'll go ahead and do it all now. We want the strength And this is really max strength. Or, you know what, let's just do strength. And then let's do bot2 name, bot2 strength. What's the name of bot2? And what is the strength of bot2? And then we just want to instantiate them. So bot1 equals new bot, bot1 name, bot1 strength. And if you notice here, we're getting an error. Why are we getting an error? Well, if this were a classroom, I would ask you live, but we know that what we showed in the first video was that we can't convert we can't pass in a string to a constructor that is expecting an int. So we need to parse that data. So let's make a method that does that. Public static int parse string int incoming. Return integer.parseInt. We did this before, right? Oh, actually, we want to take in a string that's incoming. Sorry. Incoming. So this method here, obviously, it is static because it does not belong to the instance of any class, and it returns an int, and it does the work that we want to do here to keep our code relatively dry. So we can just say parse string bot1 string. So we've got our bot1 and we've got our bot2. Now these two things are just warning us because we haven't used bot1 or bot2 to do anything yet, and that's fine because they've definitely got a work to do because they're getting ready to scrimmage. So now we have to come up with a way, we have to think of a way, okay, well, how do we get them to scrimmage? And then how do we keep them scrimmaging until we tell them not to? So what we're going to do here is we're actually going to create a container where it is a container for a scrimmage. And we're going to use a while loop. So what I'd like you to do now is I would like you to figure out how to use a while loop to keep running until the user says stop in a J option pane. So what the behavior we're looking for here is, but you want to have a while loop that keeps running and says you want to keep this process going, and if you click yes and it keeps going, whatever you click, it will not do anything until you click stop. So it says enter stop to stop this loop. So that's what you need to do right now. Come back when you're done. Okay, so the assignment up to this point was to create a while loop that had a J option pane that would allow the while loop to stop. So in other words, you would get a dialog that says, do you want to stop now? And if you clicked, whatever you type actually would determine whether or not it stops. So you press, if it says press enter stop to stop, or enter yes to stop, then it would stop. Otherwise, the while loop would keep executing. So there are several ways to do this. You could use a Boolean, you could also use a string, but you need some type of value to collect or to record, keep track of the user's input. So we can say string user input equals run. Again, lots of ways to do this, but we could do while some condition, and the thing that may have tripped you up is that if you're checking for equality here, and you're not checking for equality of strings in the right way, this may not work. So if that is something that stopped you, or that blocked you when you were just now attempting this, and that's enough of a clue to get moving, go ahead and pause the video now and fix that, and then come back. Otherwise, just keep watching. So we want a while and then a condition here, and then we want to say JOption pane dot show input dialog, do you want to stop? User input string message here equals that, and we can say user input equals message. We've already defined user input here, so we don't have to say string user input anymore. And then, so in this one here, many of you may have done while user input is not equal stop, type stop to stop. Many of you may have done this. And so when you run this, we need a name of bot 1, Charles, strength of bot 1, 44, name of bot 2, Olu, strength of bot 2, 81. You want to type stop to stop. So if you just type run, it doesn't stop, and if you type stop, it doesn't stop. Now, when you get caught up in an endless loop like this in Eclipse, you can always press this button here, this red button, and it'll stop it. So this looks right? While user input is not equal to stop, then do this. Run this loop. Now we had the user input, and many of you may have had this. You could even really do user input equals that. And many of you may have had that. And you run into the exact same problem. The issue here is that equality for strings need to be checked with dot equals. So while not user input dot equals stop, then okay, so now when we run it, our bots do you want to stop, type stop to stop, click run, but then when we type stop, it actually stops. Okay, so what we want now is we want a process for the bots to actually fight. So what we will do is we want to create a process where the first thing when we have a punch method, for example, when they punch each other, then the bot with the highest, the damage done to the bot with the lowest score will be the difference between those two scores. So for example, those two strengths rather. So if you have a bot of 10 and an 8, then the bot with 8 will be damaged by 2, so he'll now be a 6. It's not very fair at all, but it's just they're just machines, and they don't really have any. They don't feel real pain. So we'll looking at this. Then we need a way. We already have a way to increment strength. So what we want to do here is we want to have a process to have damage. The damage method would be similar to the one you wrote for incrementing. Damage and this dot strength minus equals value. So that was simple enough just to copy and paste. But we also want a way to then do the actual fight process. So what we can do is we can do a static method here in the main, in the bot start class. So in our driver class, we could do a static method here. Now we also could do a fight method in the bot class. But for the sake of simplicity, we'll write one here. So we want public static void fight. Now, when we want to fight, we want to take in two parameters. We want to take in, what we're taking in actually are bots. So we can say bot B1 and bot B2. Now what we need here is logic to calculate the winner. So we could say, well, if one is greater than the other, then in terms of strength, then we need to create some damage. Otherwise, it would be a tie. So what we'd like you to do here is write that logic. You're accepting in a bot 1 and a bot 2. And each bot, we already have an increment strength, and then we also have a damage strength. So go ahead and comment out your while loop for now, because we don't need it just right this minute. But we want a way to fight them. So what we should be able to do is say fight bot 1, bot 2. We should be able to call this method and have it do actual work. But right now it does nothing, so we need you to write the code there and come back when you're done. Okay, so the beauty of this process is there really are several correct answers, and you may have done it or designed it a very different way than your colleague. So we just want to explore ways to do this. So one way to do this, if we have a fight, bot 1 and bot 2, the first thing is we could say, well, we could say if bot 1, which is this is a bot that's been passed in, and we click in dot, we see all of the properties of that bot. So if bot 1 dot strength is greater than, or actually let's start off with equality. Then we could do system.out.println it's a tie. Then we can do else if bot1 dot strength is greater than bot2 dot strength, and then our last one will be else. The only other logical thing is that bot2 is greater than bot1. So here, if the strength is greater, then we could do bot2 int diff equals b1 strength minus b2 strength. And then now that we've got the difference, then we could say we want to decrement or damage by that amount. Now, there's even a drier way to do this, but we'll go ahead and write this now. Just writing this now, I realize, well, there's some repetition here because then we have to do the exact same thing here. So, in fact, let's just make it drier now, because what we would have to do here is create that repetition here. We say, well, else diff is b2 strength minus b1 strength, and then b1 dot damage by the diff. So that's not very dry. So how could we make this one so that we don't repeat ourselves, so that this is much fewer lines than what we have right here? Go ahead and do that, and then come back when you're done. Or if you if you had a different solution, then you can go ahead and just fast forward through until we get to the next section. Now again, there's many ways to do this. We could outsource the process of determining a winner and make that its own function as well. So, and that's something that you're free to do if you want. Because there are many ways that we could make this code tighter and cleaner. But the first thing is, if we just wanted to get this, we could then do this. So the first thing is, if it's a tie, say that it's a tie. Else, we want to get a winner. So here we would write the process to get a winner. So what may be better, instead of getting winners, getting a loser, because if we have the loser, then we can just decrement. The winner has really no effect from the fight because he won. So we could do ternary and just get the winner. So we can say bot winner, or get the loser rather. Bot loser equals b2, we could just say b2 dot strength is greater than b1 dot strength, and if it is, if b2 is stronger, then the loser is b1, otherwise the loser is b2. So then now we can do loser although, you know what, we may want to get a winner too, because we want to get the difference between him and the winner. So let's just do both. Get a winner and a loser. So if the winner, right? So loser dot damage the winner dot strength minus the loser dot strength. And then they're done fighting. So then what we can do is we can say bot1.talk. Like this is after the fight when they interview the boxers and they say, well, how did the fight go? Bot1.talk and bot2.talk. So do we have talk or is it speak? It's speak. Okay, so and this is a void method, so it doesn't return anything. It just fights them. It decrements the one that's needed, and then so we're fighting them, and then we have them both talk. So let's try it. So this time we'll fight. I don't know, Dora and Boots. So Dora has a strength of 20, and Boots has a strength of 25. So Dora was 20 and Boots was 25. So Dora lost. The difference between the two of them was 5, and she lost, and now she's 15. So we know that that initial fighting process works. So I'm sure you figured out that this would be a public Boolean depleted. You know, there's a very good argument that we don't even need this method because we have a get strength. But just for now, and we can dry this up later, we can return this dot get strength, which is this other method, is greater than negative 21. Or we could return this dot strength, just this dot strength. Then this would obviously return this property. Either way is fine. And again, you know, these two do something similar. But anyway, so we have depleted here. So then with here, we can say while the user hasn't typed in stop and the bot1 is not depleted and bot2 is not depleted, so nobody's depleted, fight them. And then so now if we run this program, so we can fight Ahsoka with 45 and Anakin, I don't even know if that's how you spell it, with 40. And we don't, let's see, bot1 dot depleted, bot2 dot depleted. So it ran without this statement here failed, so we have to look at why. So not bot1 dot depleted and not bot2 dot depleted. Depleted, return this dot strength as greater than negative 21. Oh, they're depleted if they're less than negative 21 or less than negative 20. So let's try it again. Same people with the same misspelled names. 40. All right. Anakin is lower. Nope. Anakin is lower again. Nope. Anakin's at 5. Nope. Nope. And so Anakin went below the amount we needed, and it stopped when Anakin was just totally depleted. So now what we want to do is create a regeneration thing so that after one round, we want to replenish. And we want to replenish them with a random number. So it makes it a little interesting. So somebody could start off higher, but then have a poor luck of the draw in the replenishing process. So we're going to have to deal with getting the getting a random number generator. So there are many ways to do that, but one way to do that. Okay, so I'm sure you figured out that it would be public Boolean depleted. Return, so we could just do return this dot strength is greater than -21. So if it goes below -20, they're depleted and they're done. So then here, or we can actually use an AND statement here. And we want to do an AND, say, to make sure that neither one is depleted, right? So we can say not bot 1 dot depleted and not bot 2 dot depleted. We could have done the inverse and had a method just called health. So we could have done the other way and did one called healthy, but this works. Okay, so we want a random number generator that allows our bots to replenish themselves. So in order to do that, one way to do that is to use is to import a package to get us random numbers. So we can import java.util.random. Now you may ask yourself, well, shouldn't be getting random numbers, shouldn't that just be kind of included in the language? Well, in order for the program to be as slim as possible, we only need to import the packages that we know we're going to need. It's very conceivable and common for many Java programs to never use random numbers at all. So by having imports, it allows you to pretty much have a really bare bones application except for the very, very core language features that you need. So here, we import the package. Now in order to use it, we want to write a refresh function. So public void refresh. And we want to generate a random number. So int random equals new random dot next int. I think it's next int. And when you when you pass this, you're creating a new instance of this random class thing, and you're saying you want it to be anywhere between 0 and this number that you're passing in. So the random strength that they would have, we can just give them a random strength of 10 when they refresh. That'll make it interesting. Next then ensures that it's an integer, so that we don't, get a decimal a number between two integers when we're trying to generate a random number. And then we can say this dot strength plus equals random number. So this fight could really go on for a very long time, depending on how far apart their strengths are when they first start the race. So we can refresh a bot then now. So bot one dot. So instead of here with speak, in our speak, what we could do is we could say have this speak function here do a couple of different things. So we won't call refresh in here. When we call speak, we could really name it something else, but what we want to do is we just want to say refresh. We could say this dot refresh. And then say refreshed with a power of strength. So we have them speak, they refresh themselves, and then they speak again. So this is kind of like speak in this case, you know, like I said, it's probably poorly named, but what it's really is a post-fight operation. So let's start off with another high discrepancy and just see what happens with our refresh rates. But not too high. Let's have a discrepancy of maybe 15 between the two of them. So we'll do Ernie with 30 and Bert with 23. Yeah, we'll just do 7 between them. So Ernie had 30 and he refreshed with 33. Bert had 16 and he refreshed with 23. Don't want to stop. 13 and 21, 7 and 8, negative 23 and negative 28. Negative 70, 42 and 42. So we had a clear loser here. All right, so we saw in here between Ernie and Bert. So Ernie started with, Ernie was higher to start. Bert got knocked down to 16. Bert went to 13. Bert went to 7. So the refresh rate was not enough, but it allowed him to fight back a little bit and he didn't lose as quickly. So let's try to make it a little more interesting and give them a refresh. The refresh rate would be like 20. Or a random number between 0 and 20. Again, Ernie and Bert. Ernie with 40, Bert with 35. Still going, and I lost my panel here. So to get, if you lose your panel, you can get it back by, let's get it over here. No. 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 So Bert still lost, but it took a while still. So we have a good fighting machine now. The only thing that we want to do now is that we actually want to talk about when somebody like Bert, who's an underdog and keeps losing, he's going to want some way to fight back. So Bert, we're going to give bots an option to have a mini bot that will come out and fight in their place once they're depleted. Certain bots won't have mini bots, but other bots will, and it's kind of like a secret compartment that lives inside of them that gets triggered when there's really no hope. So what we can do is we want to create out of a bot, we want to create a new class called MiniBot. So we're going to go to File, New, Class, and this will be a MiniBot. Now the MiniBot is going to extend bot. So we do public class MiniBot extends bot. Now the minute we try to do this, we run into one small issue, and that's that the bot, in order to extend the class has to have an empty constructor. The class you're extending has to have an empty constructor, so we can just do public bot like that. Then this error here goes away. So the MiniBot has everything that a bot has. We write a constructor for it just like we do for the other one. So public MiniBot. And our MiniBot will have something else, string taunt. MiniBots have taunts because they're kind of like a secret weapon, and they're going to come and basically kick butt. And we're going to have to find a basic trump card that allows them to just completely win. So maybe their strength by default is, well, let's just go ahead and write the constructor first, and then we'll talk about how we want to set up the properties. So we have a MiniBot that extends a bot. The public, you can use a constructor that's very similar. String handle, int force, and we want a string backtalk. All right, and the only reason we're using this is because we're showing you the relationship between this and that. We're going to introduce a new word here called super. This also be public MiniBot. So what super does here, so we have this constructor. It takes in a handle, it takes in a force, and again, these can be anything, but since they're inheriting from bot, we'll just keep that convention that we started there. We use crazy names to show you the relationship between tying this internal property of the class to the incoming parameters. That's why we're using crazy names like handle and force. So here, when we call super handle and super force, it is a way to tell Java to inherit these properties that were passed in the parent without having to retype all of those connections again. It was useful in very large classes. So we're doing super on handle and force, but then backtalk is something new. Only MiniBots have backtalk. Only MiniBots have taunts, and so backtalk is accepting the parameter of any kind of trash talk that's coming in, and we're tying it to the taunt. Okay, so how do we spawn a MiniBot? And so when we get when somebody starts to lose, what we can do is we can pop out the MiniBot, and we can tell the MiniBot that it needs to fight on behalf of its parent. So we have constructed the MiniBot with this constructor here. And before we go any further, we want to show you a little bit about how this works. And the other reason why we use Eclipse is that all these class methods are available to us in our instantiated objects here in our starter class, so we don't have to run the program to show you a few things. with this mini bot, we could do something like this. Mini bot Chucky equals new mini bot. Chucky $500 and his taunt is how you like me now. Now we could, if we do Chucky dot, we see Chucky has access to all of the methods that are in his parent. It has the properties of name strength. He has taunt, which come from minibot. You see how Eclipse here shows us he's getting name from bot. He's getting strength from bot. Taunt is coming from minibot. So it's a really nice drop-down menu here that shows you damage, depleted, get strength. All these comes from bot. Some of these other things, like we mentioned before, are extended from the object, which all classes derive originally from object, which is the granddaddy of all classes in Java. So Chucky has all of those methods. So what we've done here is basically showing you how inheritance works. Now there's another thing that we can do here, which is if we do public void damage, here in the old one we had strength minus equals and then the value that came in. But here we could just do public void damage and strength minus equals 1. So we have overwritten the parents method here, and the minibot, basically when you damage it, his strength only decreases by 1, so he's much harder to beat. This is called method overriding, and it should have been in your studies up to this point if you've read all the material leading up to this lecture. So what we want you to do now is to create your own minibot, and then I want you to think about a way that when somebody is basically depleted, how could we create a new minibot to fight in their place? So think about those two things and create your new minibot and then come back. The question on the table is, if we want to have a minibot that jumps out when its parent robot is losing and basically kicks butt, how do we do that? So there are lots of ways to do this. In an object-oriented environment, probably infinite ways to implement this. But one of the things that we know is that we need to give the user, or it would be nice to give the user the option of having a hidden minibot present when they create their regular robot. If both robots have minibots, then we have two invincible minibots that pop out when the parent is losing, and then we still have an infinite war. So we really should only we should urge users to only do it with one robot, but we'll give them the chance to put them on both. So we basically ask string bot1 mini equals joption pane.show input dialog. Do you want a minibot? Yes or no? Just type yes if desired. And then the same thing for number 2, for bot 2. Do you want a minibot? Yes if desired. Then we can decide, okay, so if we have this data, when we instantiate the bot, we need to decide whether or not they have a minibot and allow that minibot to be created later. So one thing that we could do is we could say, well, a property on our bot is whether or not they have a bot. We could do a Boolean has many. So what you need to do right now is when in the constructor needs to change. We could overload the instructor. The constructor. We talked about constructor overloading. We could have two constructors, one that takes a many. But since we're asking for yes and no here, and every robot you get a yes or no response, we could just put in another flag here, Boolean B. So then B equals has many equals B. So essentially, when they create a new robot, if they said yes, we want a many, then has many is a flag that is present on that bot that bot will always have. So now when we create a new bot here, we can say true or false based on what the user passed in. So instead of just simulating what the user passed in, we can use the actual data. So we can say Boolean bot 1 has many. Let's do that. Equals bot 1 many dot equals yes. So take a minute to think about that. So we take yes or no for the user. If it's yes, then we set a Boolean for bot 1 many equals yes. Then this one would be bot 2 many, 2 has many, if the bot 1 many equals yes. So then we can take bot 1 many and put that as an argument here, and then bot 2 many is an argument here. Now our minibot is complaining because now our minibot extends the bot, but it's taking in the wrong number of arguments. You see this here has a Boolean, and this one here doesn't. So we could just say here Boolean B and then super B. Now it stops complaining. So the new bot and bot 1, oops, this means to be bot 1 has, and this says bool 1, so we really want to say bot 1 has many, and this is bot 2 has many. These are the Boolean values we want. All right. So we're almost there. We're almost there. What we really need is that logic to nail this whole operation, which is when you're losing, the minibot pops out. So we fight the bots here. After we fight them, one of them may be depleted. If one of them is depleted, when we come through the while loop again, then this line, line 28, will fail, and the while loop stops, and the fight is over. But before we reach the end of the while loop, we can have a depleted robot. So for example, you've seen in our previous output down here, after we fight them, one of them might be at like -35, -50 after the fight. At that point is when the minibot needs to jump out and save the day. So we could write an if statement here let's just start with bot 1. So we want to write an if statement. If bot 1 is depleted and she has a minibot, replace him/her with the mini. That's the code that you need to write now. See if you can write that code and then come right back. The replacement code for this if statement. If the bot 1 is depleted and she has a minibot, replace him or her with a mini. So this is fairly simple. If bot 1 dot depleted and bot1 dot has many, then do this. So we know that if they're depleted and that they have a many, that we want the many to jump out. So we can say mini bot, and we'll stick with Chucky, equals new mini bot, and give the parameters Chucky, the lowercase c because it's just a little tiny bot. One about a strength of 100,000. The taunt will be you're gonna get crushed, and Chucky does not have another mini bot. He doesn't need one, he's too strong. So in our mini bot here, the backtalk we have here, so if the backtalk is the last parameter, we just need this to be here. Okay, so we've created a new mini bot, but how does the new mini bot replace its master? Very simple. We can say bot1 equals Chucky. The reason this will work is because a mini bot extends a bot. A mini bot is a type of bot. So since bot1 is a variable that represents an instance of a bot, Chucky is an instance of a bot. He's just a mini bot. So he's still a bot. So then now bot1 is Chucky, and he replaces. So we can do the same thing with, bot2, same logic. And this also is extremely not dry. So but the first thing we want to do is just get it to work. So we've got this logic in. And say, I'm the mini terror of bot2. All right. Instead of Chucky, then this one, I don't know, this one could be called Pinocchio. All right. So let's fight the bots. So we'll start. We'll do Ernie and Bert again. So Ernie will start low at 20, but he's got a mini bot. Bert will start higher at 40, and he has no mini bot. So Ernie is already pretty low, and Bert is winning. So we don't want to stop. Ernie is dropping, Bert is rising. Ernie is about to get crushed, and will his mini bot come out? No. Ernie, okay, it looks like Ernie is failing. And now Chucky has arrived. So you see now, Chucky arrived, he has a power of 1,000, and Bert got crushed down to negative 99,000. And we have a winner, and that winner is Chucky, the mini bot that was spawned from Ernie. So we've talked about a lot of different concepts here. We've dealt with method overriding. We talked a little bit about method overloading, but we're going to go a little bit more into that now. But if you've gotten this far, you should have an understanding of how to create instances of classes and how to write mutator methods, getter and setter methods to change the state of those methods based on interaction with the user. So before we go, we're going to talk a little bit about abstract classes, and it's a fairly simple concept. We can go and create a new class, and we'll call this class, I don't know, mechanism. It'll be an abstract class. So a bot is a mechanism, and a blender is also a mechanism. So an abstract class, we could create an abstract class called mechanism that eventually will branch off into various different types of mechanisms like irons, toasters, robots, etc. So an abstract class is a class that is never directly instantiated. You never create a new mechanism, but you extend it to create other mechanisms. And those mechanisms you do instantiate. So for example, if we had a subclass here, like let's say all of our mechanisms will um, um, power on. So we would have a public void power on. So if we have a bot here, the bot, if it extends mechanism, it's generally understood that if you have an abstract class, that the different methods that are in that class, you generally want those methods then will be used by the child classes. So for example, if you run this, or actually we want to start by saying, let's just, before we do anything, we could do bot Rusty equals new bot Rusty 100 false. And Rusty dot power on. I am powering on. So that's pretty simple, right? So the abstract classes, just remember there's a class that's never meant to be instantiated and it's going to be extended. You can't do new mechanism. If you try to do that, bot Rusty equals new mechanism we get the error. Cannot instantiate the type mechanism. Even if we try to do mechanism Rusty equals new mechanism, we get the same error. Cannot instantiate the type. So that's pretty self-explanatory. So that is dealing with abstract classes. So here, we have mechanism which begets a bot, which begets a mini bot. So it's a chain, a hierarchical chain. And all of the methods that are in the parents get passed down unless they're overridden. Like in this case, we overrode the damage method. Another thing we'll briefly touch on are interfaces. An interface is kind of like an abstract class, but the difference is that you can implement many interfaces. So we'll just create a new interface, and the interface will be called a button. Public interface button, and then you just put stubs for methods that will be implemented in different ways by the different things that implement them. That was a little redundant, but you'll see what we mean. So if we do public void push, this is a method, but we don't put the double curly braces because this method is not meant to be fleshed out here. It's meant to be fleshed out in whoever extends it, whoever implements it. So we use extends to extend an abstract class. We use implements to implement an interface. So you could say implements button and then implements these other things. Now we're going to get an error here because we don't have, we're implementing an interface, but we haven't done anything we don't have something called push in our bot. So when you implement an interface, you have to use the member methods, and that'll tell us that here, right? So must implement inherited abstract method button push. So we just have to say public void push, and then this dot we're getting a power on. This dot power on. So here we have an interface that is invoking a method that's coming from the abstract class that it's extending. Thanks for watching. If you finish this video, you should now have the basic skills to create new classes and instantiate objects based on those classes, extend classes, extend abstract classes, implement interfaces, and to manipulate these objects so that they can do what you want. So this concludes the introduction to OOP with Java.